revisions. Eric, do you still remember the story?
Yeah. Was it the Elise one?
Yes, the Elise one.
Elise charges Ronaldo's EV car using a magnet and gets electrocuted.
Yes.
No, charges Ronaldo's EV car in Silly Park with a magnet and gets electrocuted. That one was it.
Yes. Excellent. So with this story, can you tell me the drawer's name in sequence?
So the
The
first
first
one
drawer. What's the name of first drawer?
was electric charge, I think.
Yes, you're right. Number two?
Number two was voltage, current, and electric current, voltage, and uh, think. Wait, no, wait.
Cristiano Ronaldo. The R.
Oh, resistance. Is it?
Yes. Okay. Number three?
Number three um Earth
Not yet. The
magnetic
silly
field.
part.
Oh,
The silly part is
the
number three.
silly part parallel and series circuits.
Excellent. Number four?
Number four, that one would be um magnetism,
Yes, because
Earth's magnetic field.
yep, magnetism is fine because Elise is using the magnet to charge, right? So that
Yeah,
magnet represents the number four. Number
right.
five?
Electromagnetism.
Yes, because she got electrocuted. So electrocuted represent electromagnetism.
Yes.
Right. So now this is the first step. When you do revision, there are a few steps. Let me just share my screen. Yep, this screen. Right. The first step is to remember the drawer of the main story, the main story for the drawer, which is for this case will be this Elise got electrocuted story. Right. So what I'm trying to teach you today is not just electricity and electromagnetism, not just the physics. I'm trying to teach you how to do revision after you have done the 2 to 3 hours class like what you did last week. Right? Why is this revision important? It's because when you want to prepare yourself for exam, you need to do revision. And the more revision that you do, the better you're going to remember and to understand the chapter. Right? And I'm going to teach you how to do it. So it's going to be in a very systematic way. So you don't need to be worrying about where to start, where to end, and how to do it. I'm going to teach you this step 1 until step 6. You just need to follow this step 1 until step 6, and then that revision session is done. Remember last week we had this step 1 until step 9, and that took us about 2.5 hours. So that 2.5 hours, I think you get 9 out of 10. What does it mean? It means that you understood the chapter well at that time, last week. Today, if I test you again, maybe you're going to get still 9 out of 10 or even 8 or 7 out of 10, which is normal because it's already 1 week apart. And you tend to, or human tend to forget after a while. That's why we need to do revision. And that's why I'm teaching you how to do revision. So your understanding will constantly either maintain or increase over time. Right? I hope it is clear. Okay. So first step, you're doing you did what was being required as a first step. Remember the main story, and that will help you to remember the drawer in sequence. Very important, in sequence. So this is done. Now, step number 2, I would like you to read the keynotes. Right? You can read the keynotes by yourself. You don't need to read it out loud. You'll get 1 minute for you to 2 minutes for you to read, right? So that you can refresh a bit on what you have learned last week. Let's do it now. 2 minutes. Thirty more seconds. If you have finished reading, you can read it again and again until we finish the timer. Okay, 2 minutes up. So what am I trying to do here, Eric, especially? I'm trying to help you to refresh what you have learned last week, right? By reading this, I hope that you are able to retain most of the things or most of the information that you have read, or most of the understanding that you understood last week, right? So you know that there are 5 drawers: electric charges, current, voltage, resistance, series and parallel circuits, magnetism, and electromagnetism. And now you also know that, I hope that you also did the refresh on what was inside drawer number 1. You have protons, electrons, neutrons. You have the charges. For proton is positive or electron is negative, then it will react in a way that whether it is going to be repulsive or attractive depending on the charges. Then there is the electron transfer mechanism, how it's being created, the transfer of electron. For drawer number 2, the definition of each of them, which is the current, voltage, and resistance. So the definition is very clearly stated over here for each of them. And also the unit that's being used for each of them. And the device that is being used to measure the current or the voltage, which is potential difference, right? Then drawer number 3, you have 2 different circuits, and they are opposite to each other: series circuits and parallel, right? And there's this definition for each of them. Then magnetism, you have the north pole and south pole. Electromagnetism, you have the electromagnetic electromagnet, where you can control the strength of the electromagnetism based on the loops of the coil, the current, and also the type of the material, whether it's iron or steel or something else. And there's applications that's being used using this electromagnetism. So this to give you a refresher. Now, step number 3 is explain each drawer story. Right? What time did we start? Let's start time is 8. What time is it now? 8:40. Oh, let me see. Okay. I think we started at 8:40. Now it's 8:50. Yes. So now step number 3 is explain each drawer. Okay, let's go into the bracket. The bracket is the short story that I created for each drawer. And the story doesn't make sense. It is a silly story. And that is the purpose. That is the reason. I need to have emotion in it to create long-term memory. Now, first drawer is a pen couple. There's a couple, happen to be a pen, a boy and a girl, and they are attracted to each other, and also they fight with each other. So now imagine you have, right in front of you, you have 5 drawers. 5 drawers in front of you, and each drawer is having their door. So you have to open the door to see what is inside each drawer. Now all the 5 drawers are closed. The door is closed. So Eric, Eric and Shen, imagine that you open the door of the first drawer. You see nothing inside. There's nothing. It's blank, empty. Now I want you to fill up objects or items inside the drawer to help you to remember what is inside the drawer and what is the story of the drawer easily. So this is the story. You have this pen. So obviously you have one pen, let's color it as blue, another pen, color it as pink. So you have a blue pen, you have a pink pen. And this blue pen and pink pen, you put it inside your drawer number 1. Okay? You put it inside your drawer number 1. That represents the boy pen and also the girl pen. And they fight with each other, and also they attract to each other. That is to help you to remember the keywords in this drawer. Now, close the door of drawer number 1. Okay? The name of the drawer number 1, the label is electric charge. Okay? Done. Drawer number 2. Open the door of drawer number 2. What do you see inside? Let's try Shen. What do you see inside drawer number 2?
Current, voltage, and resistance.
Okay, you are too advanced. You see nothing inside drawer number 2, right? Because we haven't filled up anything inside. Okay, so what we are trying to do now is we are trying to fill up something inside drawer number 2, right? Using the story. So what's the story? The story is you push a vampire and he turns around and bite you back with this sound. This sound sounds like Om, right? I hope it does. At least it does for me. Okay. So imagine, okay, why this story? This story is you push the vampire. Okay. Vampire push is to represent this potential difference. The definition of the potential difference is to that push that cause the charges to move around a circuit. All right. So this push is to help you to remember that there is this term push related to this drawer number 2, and it will be related to the definition of potential difference. And vampire, the V also is can be used to represent volt. So volt is also voltage. Ampere sounds a bit like empire. So this vampire have two rows, voltage and amperes. And he bite back ohm. Ohm is the resistance, the unit for the resistance. Right. So this is the story, the short story to help you to explain the content of this drawer. Now, Xuan, open the drawer of drawer number 2, and the name of drawer number 2 is current, voltage, and resistance. Put yourself inside drawer number 2, and also put a vampire inside drawer number 2. Okay, and that's it. You can close the drawer, close the door. Okay, hopefully the vampire doesn't kill you. Now, open the door of drawer number 3. Xuan, again, what do you see inside?
The topic num.
Nothing, right?
Yeah.
Nothing, because we haven't filled anything inside. Drawer number 2, you have something. Drawer number 3, you have nothing. As of now, which is what we are trying to do now. Okay, Inje is here. Let me admit her. Good morning, Inje.
Morning.
Okay, we started maybe 10-20 minutes ago. So you try to follow. If not, then you can ask me, right? So I'll continue. So drawer number 3 is empty now, right? But before that, Eric, can you tell me what is inside drawer number 1? Open the door of your drawer number 1 now. What is inside?
It's about protons, electrons, and neutrons.
Okay, you are too advanced. I'm just asking what is inside your drawer number 2 now. What are the objects or items that is inside your drawer number 2?
The current, the like the thing that says the vampire.
No, that's. Oh, did I ask drawer number 2 or drawer number 1?
First time you said drawer number 1, and the second time you said drawer number 2.
Okay, then I confused myself. Okay, let's focus on drawer number. Oh, let's focus on drawer number 1, right? Oh yes, I think to be fair, I did not explain well enough why pen. Pen represent P for proton, E for electrons, N for neutrons, right? Okay, for the benefit of Yinjie and also the benefit of the Eric and also Xuan, let me tell you what I'm trying to do now, right? I'm trying to fill up items inside each of your drawer. As you remember, you have 5 drawers, right? The 5 drawers are here. Electric charge, current, voltage, resistance, drawer number 2. Drawer number 3 is series and parallel circuits. Drawer number 4 is magnetism. Drawer number 5 is electromagnetism. Right, this is the story that helps you to remember these 5 drawers in sequence. Right, now, earlier I asked Eric and Xuan to imagine in front of you there are 5 drawers. And all 5 drawers are having their own door that is closed. And now we open the door of the first drawer. And this first drawer, we put in 2 items. The blue pen and also the pink pen. Pink color pen and blue color pen. Why pen? The pen that you use to write and draw. Why pen? Is because it's related to this story. A couple, the pen, they're attracted to each other and they fight with each other. Why pen? Why I use pen is because P linked to proton, E electron, and neutron. So when you think about pen, you can link it with proton, electron, neutrons. Right? The abbreviation of pen, P-E-N, or the spelling of pen. Right? And this couple, the boy and girl, obviously they are attracted to each other. That means attractions. And also sometimes they fight with each other. That means repulsions. Right? This story is to help you to remember the key informations inside drawer number 1. By just imagine that there are two items in drawer number 1, blue pen, pink pen. Okay, so drawer number 2, you push a vampire and he turns around and bite you back. And when he bite you back, he create the sounds. You know, when you're biting something, it's like sounds like om. When you push something, okay, this push word is related to the definition of voltage. And the vampire start with V. V also, you can use it to represent voltage. The empire, it sounds like amperes. So represents the unit of current. And the ohm is the unit of resistance. So this is to help you to remember the key informations inside the drawer number 2 by using certain items, right? For this drawer number 2, the items or the object that you use is yourself and also a vampire, a bloody vampire that likes to drink blood and she likes to bite you. He wants to bite you. Okay, so drawer number 2, when you open the door, what do you see inside? Xuan, what do you see inside drawer number 2? Who is inside?
Vampire.
You and the vampire, right?
Yeah.
Yes, and what happened to you and the vampire? You try to push the vampire away and he tries to bite you back.
Yeah.
Right, this story itself can already give you some idea what is inside drawer number 2. Right, drawer number is talking about voltage, talking about ampere, which is current, talking about ohm, which is resistance. Okay, I hope you are following. Everyone is following. At least Eric and Xuan and Yunjie. Yunjie, are you following? You are the last one who came in. If you can follow, I'm sure the rest can follow. Yes. Okay. I think Xuan can follow. Eric, I'm quite sure that you are following also, right? Jaden, you have to catch up, right? So that is drawer number 1 and drawer number 2. The item that is inside drawer number 1 and item that is inside drawer number 2. Now close the door for drawer number 1 and drawer number 2. Don't let the vampire goes out and don't let the pen run away. Okay. Open the door of drawer number 3. Eric, what do you see inside drawer number 3? Now, what do you see inside?
It's the Sarah says no, Papa flows faster.
Okay, I think you are also too advanced. Now you see nothing, 0. There's nothing inside because we haven't put anything inside yet. Right? Okay. Good to be advanced, but as of now, we haven't have anything inside yet. And that's what we are going to do later, right? Now, drawer number 3, there's nothing inside. Empty, black. Okay. So what you're trying to fill up is this story. Okay. The story is Sarah says no. Oh, yes. Sarah rings. Sarah is Eric's mommy and also is Xuan mommy, I think. Right. Mommy, your mommy, Xuan, your mommy name is Sarah, right?
Yeah.
Ah, okay. Because I don't call her Sarah. I call her Chinese name. Right. So, okay. Sarah says no. Papa flows faster. So your mommy says no for Eric and Xuan case. And then your papa flow faster. Why Sarah says no? Sarah is representing the series circuits. Papa is representing the parallel circuits, right? So series circuits is there are 2 different type of circuits, and series circuits is the one that is usually not many people wants to use because the design is not good, right? Parallel is usually the design the circuits that we are all using in your house, in your schools, how you turn on the switch, Usually they are all being designed based on parallel circuits, right? So Sarah, the S represents series, says no. No represents something negative. So series is something that we try to avoid. And also, when you add in more component, every component will have their resistance. The resistance increases. So resistance is also something that is negative. When the resistance is increasing, that is something not good. So Sarah says no. No, that is to explain a little bit about what is inside drawer number 3 and sub-drawer series. Okay. This is my story. When you fully understand how the method, then you can create your own story that maybe makes more sense to you, right? I'm sure not all the stories that I made is making full sense for everyone, but that is fine because you can make your own story later. Parallel, so Papa flow faster. Yeah, when your mommy say no, Papa run away, right? And I did not say run away intentionally because flow represents the current, right? So parallel, the current increases, the total current increases as more branches are added, which is a positive thing, right? So that is the story for drawer number 3. So what should you fill up in drawer number 3? I think you will put your mommy inside for Xuan Xuan and also for Eric case. For Yunjie and Jaden, you can think about somebody who, or you can put Auntie Sarah inside, since you know Eric's mommy also. Okay, and then you can put your Papa inside. Okay, Papa is flowing faster. Okay, so drawer number 3, you have 2 person inside. Your mommy, Sarah, and also your Papa. Okay, so close that drawer. Now you have 3 drawers filled with something. Drawer number 4, when you open, Eric, what do you see inside?
Nothing.
Yes. You know the trick now. Okay? This is where we are trying to fill up the items, the correct item inside the drawer number 4. Now, drawer number 4, the story is Iron Man fly from North Pole to South Pole. Right? Iron Man fly from North Pole to South Pole. Why? How does this story relate to this drawer number 4? If you remember, the drawer number 4 is talking about the Earth. The Earth is also a magnet by itself. So there's a North Pole, there's a South Pole, right? And the magnet needs iron or steel, different materials, to be magnetized. And then you have magnetic field, right? So that is the characteristic of magnet. So Iron Man represents the iron. Fly from North Pole to South Pole represent the Earth. So this story is telling you that there is something related to the iron in the content of the drawer, and also something related to the Earth. Okay. So obviously, you have to put something inside your drawer right now. I will put an Iron Man. I think everyone knows who is Iron Man. Who doesn't know? Who doesn't know? Raise up your hand. 3 seconds. 1, 2, 3. Okay, everyone knows Iron Man. And Iron Man is flying from North Pole to South Pole. That means it's an Earth. So put an Earth inside your drawer number 4. So you have Iron Man and also Earth inside drawer number 4. Okay. Now close drawer number 4 and open drawer number 5. And obviously drawer number 5 now is empty. Nothing inside. 0. So what is the story for drawer number 5? A coil Iron Man fly fast. A coil Iron Man fly fast. This Iron Man and the Iron Man that you had in drawer number 4 is different. It's coil. Something like this. Okay, if you can see my drawing clearly, I don't know. I'm not a good drawing artist. You can see clearly from here. So this Iron Man, his head is here, his hand his leg, and his body is being coiled. Right, and it's flying so fast. This is like an arrow going to this way. Right. So drawing number 5, you have a coil Iron Man, not any Iron Man, but a coil Iron Man, and he is flying very fast. Drawing number 5. Now let's do a recap. Let's do a quick recap. What do you have in drawer number 1? Eric, open the drawer number 1 door and tell me what is inside drawer number 1.
It is a pen couple attracted and fight each other.
Right, good. So that is the story, right? Inside the drawer number 1, you have 2 pens, blue pen and pink pen. Right, then that story will come along as you are able to imagine the 2 pens inside the drawer. Right, and then the content of the drawer number 1 will also come along when you able to explain what is the story between these two pen, the boy pen and also the girl pen. Right. Now, Xuan, tell me what is inside drawer number 2. Open the door and tell me.
Me pushing a vampire, and then the vampire is trying to bite me.
Yes, yes. And this is associated to the current, voltage, and resistance. The definition of them, of each of them, and also the unit that's being used. Right. And hopefully with this association from the items, which is for this case, the not item, object, yourself and the vampire, and then you link it with the story between you and the vampire, and then you link it with using the story, you link it with the content that you have read in the textbook that's related to the current, voltage, and resistance. And also the relationship between these three, V equivalent to IR. Right. Yunjie, open drawer number 3. What do you see inside?
Sarah says no, Papa goes faster.
Right. So you see Auntie Sarah inside, and you see Papa flow faster. Right. And this story, hopefully, is going to help you to remember the content that is inside this drawer. Okay. Jaden, what do you see inside your drawer number 4? There are 2 items. Two items inside your drawer number 4.
Iron Man, not positive softball.
Yes, you see an Iron Man and you see a globe or an Earth. Okay, inside your drawer number 4. And then with that Iron Man and also the Earth, it's easy for you to remember the story. Iron Man is flying from North Pole to South Pole. And with that story, I hope it's going to be easy for you to relate it with the content in the textbook. The content in the textbook is talking about the Earth and also how Earth is having its own magnetic field, how magnet works, right? Let's go back to Eric. Drawer number 5. What is inside drawer number 5?
Nothing.
What nothing?
Something.
Yes, what is inside drawer number 5?
The cold Iron Man 5 has.
Yes. the coil Iron Man, not the normal Iron Man, the coil Iron Man, right? And the story is he's flying very fast, right? Why coil Iron Man? Why flying very fast? He's talking about this part, right? Talking about electromagnet. If you want it to be stronger, you need to coil more loops. And the current that is running on the coil over the Iron Man body, if it is a stronger current, then the magnetic the strength of the magnet is stronger. Okay. Why iron? Because iron is a material that is used to easily being magnetized. You can also use steel, but it takes longer time. Right. So this is the next step. Explain each drawer story. So we have already gone through step 1, 2, and 3, right? By now, especially Eric, because you started from the first second when we started the class. By now, I think that you should be able to refresh on what you have learned last week. Maybe not 100%, but a large part of it. Do you feel it?
Yes.
Yes. Okay. And I hope Yunjie also, right? Although you came in a bit late, but it's not too late until you are missing something, because we also went back and revisit what you have missed just now. Right. Do you have the same feeling, Yunjie?
Yeah.
Okay. Jaden, I hope you are following. Okay. Now, next, by right now, I will ask you to get a pen and paper and draw at least one time this ugly picture. Do you have pen and paper? Do you want to do that now? This is to help you to reinforce yourself on the story. Okay, I'll leave it to you. I'll give you 3 minutes to draw. Okay, let's stop first. I'll not give give you 3 minutes. I'll start the timer later. What you need to do is very simple. You need to draw the story. The story is the Pan story, the vampire story, the Sarah and Papa story, the Iron Man with the Earth story, and also the Iron Man with the Koi Iron Man story. Right. You can draw it on a paper, and I'll give you 3 minutes. If you don't feel like drawing it, then draw it using your mind. Okay. Do something in these 3 minutes. I'll leave it to you. My suggestion is take out a paper, take out your pen, and draw it. Okay, 3 minutes. Start now. Okay, 3 minutes is done. You need more time?
More time.
Yes.
Yes. Okay, 3 more minutes. Okay. You need more time? Anyone need more time? Or you have done? Eric is done.
Done.
Done. Okay. Shen, I think done. Jaden, you're done?
Yes.
Okay. Now, let me tell you why we are doing this. Imagine you took 5 minutes. I don't know how long you take, but definitely more than 3 minutes. You took 5 minutes for this to draw this picture. When you are in an exam hall, how many chapters do you usually take in a year for your science?
Like
Maybe
every month.
every month you have an exam?
Yeah.
Ah, that's good. So let's assume that you are taking two chapters. You have to take exam for 2 chapters, right? And this is the chapter number 1, and there's another one, chapter number 2. And if you take 5 minutes to draw this picture, and another 5 minutes to draw another picture, that means you took 10 minutes. 10 minutes away from, I don't know, the exam, maybe is 1 hour. And out of the 60 minutes, 10 minutes is used to draw these 2 pictures. I think it's too long, right? So by time when you practice more, you'll be able to practice it in if you can do it in less than 1 minute, then you only need to spend 2 minutes out of 60 minutes, right? Why this picture is important? I think by now you can already feel it, right? What is the purpose of me requesting you to, it's okay, Shen, requesting you to draw this picture, right? Because this picture effectively is going to help you to retain almost all the information and understanding that you have read in the step 1 until step 9. Do you feel the same? Do you understand what I'm trying to say here? Eric? Yes. Injay, do you understand? Yes. Jaden? Yes. Okay. So just now we went through a very quick exercise where you link certain items, or you put certain items or object into each drawer. And that drawer is, when you open the drawer, you see those items. And those items is able to help you to retain the story related to the items. And that story will help you to retain the informations inside each drawer, right? So that means that this picture will help you to effectively remember what you have studied and learned for the exam. And you are able to draw, if you are able to draw this in less than 1 minute, that means you are actually bringing your book into the exam, right? Okay, now we have done step number 4. Let's do, I think I have one more step. Step number 6 is watch video. Okay, then step number 7. So let's read the summary quickly. The summary that we have read before in step 3. To refresh your understanding about this chapter. Okay, what I'll do, I will.
Oh my God! Can you stop? Stop what? So loud.
Okay,
That's just how I breathe.
Xuan,
What?
Xuan, you have something to say? Okay. Now. So let's read this using the same method, same drills. I'll give you 1 minute, you read this. And then I want you to intentionally relate it with the information inside each drawer. And also now you have additional picture for you to refer to. And I'll put my picture here. Of course, I think it's better for you to refer to your own picture. All right, let's do that. Okay, let's do this one for 30 seconds. Let's read this one for 30 seconds. All right, 30 seconds is up. So why am I asking you to do this? Because I want you to refresh on what you have learned last week using the picture and using the keywords. Okay, let's do this 1.2. 30 seconds also. Let's start now. This is drawer number 1. Okay, let's do the same drill for drawer number 1, 1.3, which is electron transfer. Okay, is 30 seconds good? It's a good timing for you guys, or is it too fast or too slow? It's good. Okay, if you need more time, tell me. All right, so now let's continue to draw number 2. Let's read from here. Let's start. Okay, let me repeat just in case you're not following. Read this one and tell yourself, ask yourself which drawer is this, and then relate it with the picture and also the keywords. Let's start now. Okay, 2.2, half minute. Okay, 2.3, 30 seconds. Okay, 2.4, 30 seconds. Drawer number 2, point number 4 here. Oops, sorry. Okay, done. Now drawer number 3. Drawer number 3, just refresher a bit. You have Sarah and your papa. Okay, Sarah and your papa, which is, let me just scroll down. Okay, this one, this story. And let me scroll down. Yep, this keynotes. Oops, here. Oh, okay, you refer to your own story. Okay, the picture, because it's too cramped over here. So let's start now. Let's read this. Okay, 3.2. Let's start now. Okay. Now drawer number 4. What is inside drawer number 4? You have Iron Man and you have a Earth. You have an Earth, right? A globe, an Earth, in an Iron Man inside your drawer number 4. Okay. And the story is the Iron Man is flying from North to South Pole. Okay, let's read this in 30 seconds. Okay, done. 4.2. Whoever who haven't finished reading 4.1, you can read over here also. Let's start. 30 seconds. All right. Drawer number 4. Number 5. Last drawer. Last drawer. Remember, we have this coil Iron Man. This guy, coil Iron Man, and flying fast. Flying fast. Coil Iron Man flying fast. And why coil Iron Man? By now you should know this one. If not, I hope by reading this, it will give you more understanding in why coil Iron Man. What's the relationship? Right? Okay, let's start now. Okay, 5.2. Let's start now. The coil Iron Man. Okay, last one, 5.3. Start now. Okay, that's it for these steps. I hope everyone is following. Right, whoever who is unable to follow or have any questions, you can raise your hand. I'll give you 5 seconds. 1, 2, 3, 4, 5. Okay, so I'll assume everyone is following 100%. Now, okay, so next is to watch the video. Watch the video. Okay, I need to share the screen again. Wait. Where is the video? Oh no, where is it? Where is it? Okay, let me open another new one. Okay, I think you know the drills. how to watch the video. You need to intentionally ask yourself which drawer this video or this part of the video is talking about. Right? Drawer 1, 2, 3, or 4, or 5.
Have you ever wondered?
Can you hear the guy talking just now?
Yeah.
Yes. Okay, so let's start now. 7 minutes. Intentionally ask yourself if this is drawer 1, 2, 3, or 4, or 5. All right, let's start now.
What connects that little zap of static from your sweater to a massive train that floats above its tracks? Well, today we're going to pull back the curtain on the invisible forces that make it all happen. We're diving into the fundamental building blocks of our world, electricity and magnetism.
So let's kick things off with something that looks a whole lot like magic. If you just rub a balloon on your jumper, you can actually bend a stream of water without even touching it. And no, this isn't a camera trick. It's a huge clue to one of the most powerful forces in the entire universe. So what is going on here? Really, what invisible force is strong enough to literally pull water sideways through the air? The answer is hiding inside every single atom.
Here's how we're going to break it all down. First, we'll start with the spark itself, what electric charge actually is. Then we'll figure out how to get it moving, and how to build roads for it to travel on. After that, we'll meet its mysterious twin, magnetism, before, and this is the best part, we bring them together to see how they completely change the world.
All right, first up,
All right, this is obviously drawer number 1. It lists charge, right? It lists charge, which is electric charge. And in drawer number 1, what do you have inside? You have 2 pen, a blue pen and a pink pen. Why pen? Because pen is proton, electron, neutron. And why blue and pink pen? Because they are attracted, which means attractions, and they are repulsion. Repulsion means they are fighting sometimes, right? And of course, they also have this electron transfer. Okay.
Electric charge. This is really ground zero. It's the fundamental property that kicks off every single thing we think of as electric, from a tiny spark of static to a massive bolt of lightning.
Okay, so everything, you, me, the air we're breathing, is made of atoms. And inside those atoms are even smaller bits and pieces. For us, the ones that matter are protons, which have a positive charge, and electrons, which have a negative charge. Most of the time, they balance each other out perfectly, so objects are neutral. And these charges follow one simple, universal rule. Opposites attract and like charges repel. So 2 positives will always push each other away. Same for 2 negatives. But a positive and a negative, they are drawn together. That attraction, right there, is the engine behind everything we're about to explore.
So let's go back to our balloon. When you rub it on that jumper, you're not creating charge. You're moving it. You're literally scraping those little negative electrons off the jumper and onto the balloon. Now the balloon has way more electrons giving it a negative charge, and the jumper is left with a positive charge. And what do opposites do? They attract.
Static charge is pretty cool, yeah. But the real game changer.
Right, this is drawer number 2. Remember when you open the door of your drawer number 2, what do you see inside? You see yourself and you see the vampire. Right. So now I hope that you also remember the story, what happened to you and the vampire. Right? So they are current, resistance, voltage. This is the Cristiano Ronaldo EV car. Cristiano Ronaldo EV car.
The thing that powers our entire modern life is when we get those charges to move. That flow is what we harness for power.
When those charges start flowing in a steady stream through something like a wire, we call that an electric current. A good way to think about it is like a giant rope loop. The current is just how fast that rope is moving past you. We measure this flow in amperes, or just amps.
But, what's making the charges move in the first place? They need a push, right? That push is called potential difference, or what most of us just call voltage. In our rope model, the voltage is the person who's actually pulling the rope, giving it the energy to get going.
And finally, there's always something trying to slow things down. That's resistance. It's basically a measure of how hard it is for the current to get through something. Back to our rope analogy, resistance is like someone else grabbing onto the rope, creating friction and making it harder to pull.
Okay, so we've got the push.
Okay, now we are on drawer 3. Open the drawer. What do you see inside? You see Sarah and you see your papa. And Sarah is saying no, and papa is flowing fast. Right? And that is, if you translate into the Elise story, Elise got electrocuted story, that is the silly park. Let's start now.
And the flow, current. But to make them do any useful work, we have to give that current a complete path to travel on. We call these paths circuits, and they basically come in two main flavors.
First, you've got a series circuit. Think of this like a one-lane road. All the current has to flow through every single component, one after the other. There are no other options. Then you have a parallel circuit, which is more like a highway with multiple lanes, or branches. The current splits up and can take different paths.
You've definitely seen a series circuit in action if you've ever dealt with old, cheap Christmas lights. Remember those? Because it's all one single loop, if just one of those tiny bulbs burns out, it breaks the entire path. And poof, the whole string goes dark. Super frustrating.
So here's the crucial difference. In a series circuit, every bulb you add increases the total resistance, and all the bulbs get dimmer. But in a parallel circuit, every new bulb you add on a new branch actually decreases the total resistance of the circuit, letting more total current flow from the source. This is why you can plug in a toaster and your lights don't go out. Our whole world is built on parallel circuits.
Okay, let's switch gears for a second.
All right, let's switch to drawer number 4. What is inside drawer number 4? Imagine the items that is inside drawer number 4. Pull them out. They are the Iron Man and the Earth. And the Iron Man is flying from North Pole to South Pole. All right. So if you translate into the Elise got electrocuted story, that is the magnet that she used to charge the EV, magnet. So the drawer name is called magnetism.
For the longest time, people thought electricity was its own thing, but it has this mysterious, invisible partner that plays by very similar rules, magnetism. It shapes everything from your fridge magnets to the planet we live on. And here's the amazing part. We can actually see this invisible force at work. If you sprinkle tiny iron filings around a magnet, they'll snap into a pattern. They're tracing the lines of the magnetic field, showing us the shape and strength of this invisible region of force.
These patterns are like a map. The lines always point from the magnet's north pole to its south pole. And look here, see how the lines are all bunched up and crowded together at the ends? That's where the magnetic field is the strongest. Now, this doesn't just apply to small magnets. Our entire planet acts like a gigantic bar magnet. It generates this massive magnetic field that surrounds us, and that's all a compass is doing. It's just a tiny magnet that's free to spin around and align itself with the Earth's giant field. And now, this is where it
all right, the last drawer. When you open the drawer's door, electromagnetism, what do you see inside? You see a coil Iron Man. A coil Iron Man, and it's flying fast. All right, and that, if you relate to the Elise got electrocuted story, and that is the last part, the electrocuted. Electromagnetism is the drawer's name. Let's start now.
all comes together. This is the moment that changed absolutely everything. For centuries, we were wrong. Electricity and magnetism aren't separate forces at all. Turns out they are two sides of the very same coin. A moving electric charge creates a magnetic field, and a moving magnetic field creates an electric current. This connection is the engine of our modern world.
This discovery is incredible. When you run an electric current through a wire, it creates a magnetic field around it. And if you coil that wire up, the field gets way, way stronger. That's an electromagnet. And its superpower? You can turn it on and off just by flipping a switch.
So what can you do with a magnet you can turn on and off? Well, you can do some truly mind-blowing things, like lifting an entire train right off its tracks. These maglev trains use powerful electromagnets to float, completely eliminating friction and allowing them to hit speeds faster than a Formula One car. And this very same principle is the beating heart of every single electric motor. You run a current through a coil, which turns it into a temporary magnet. You put that near a permanent magnet.
The push and pull, the attraction and repulsion between those two magnetic fields creates a force that makes the coil spin. It's that simple, and it powers almost everything that moves in our lives.
So just think about that journey. We started with the simple idea of opposite charges attracting, and we ended up with levitating trains and the spinning motors that run our civilization. By understanding how these two fundamental forces are connected, we've unlocked unbelievable power. It really just leaves you with one question, right? What are we going to build with it next?
Okay, that's for the watch video. Before we go to MCQ, which is the last part, then we are done with the class. Let me do a quick review. Now, you understand that there are 5 drawers, and these 5 drawers are as follow. This one, right? Electric charge, current, voltage, resistance, series and parallel circuits, magnetism and electromagnetism. Now, if I ask you to explain what did you learn in electric charge, drawer number 1? Are you able to explain in a few words? Do you think so? Shall we try? Let's try Eric. Eric, tell me what have you learned in electric charge?
I learned that electric charge, it needs it has protons and neutrons that decide which direction that decide whether the thing has a positive charge or a negative charge.
Yes. Yes. That is point number 1, right?
Yeah.
If you want to go a bit more detail, you can start talking about proton is positively charged, electron negatively charged, neutron neutral. Right. If you want to go a little bit more detail, you can also say something about repulsion and also attraction. How repulsion happen, how attraction happen. Then if you want to go a little bit more detail, you can talk about the balloon and the jumper story, which is talking about the electron transfer. Once the electron is being transferred, then you have less electron, then you are more positively charged for that particular items. Or the other side will be more negatively charged because the electron is transferred to that other items. So with that, effectively, you already cover the entire electric charge, right? So any question that is related to the electric charge that is coming out from the exam, you are good to answer. And it's really depending what level, how much depth do you want to answer, because you have all the answer now at your fingertips, right? So this is when you are able to reach this level, this means that you are already understanding this drawer or this sub chapter of this big chapter, which is called electricity and electromagnetism, very well. Whether you are going to be asked question on MCQ or an essay question or just any questions like just now what I asked you. Tell me or explain me what is electric charge, right? So same goes to drawer number 2. Maybe I will try to test Yunjie. Yunjie, tell me about what you have learned in drawer number 2. If someone is asking you, explain to me what do you know about current, voltage, and resistance?
Okay, so current is measured in amperes, and it's like the push in, or like, no, not the push, the amount of charge that is going. And then voltage is like voltmeter, and it's it's also known as potential difference, PD. And then resistance is like stopping the electric charges to pass, and it's measured in ohms.
Yep,
And
excellent.
then the equation is current times resistance equals to voltage.
Excellent, excellent. I think you have done it very well. Right. So what is the role of this picture? Is to give you an idea what is inside the drawer. So when you are in exam, you do not need to be anxious or worried that you forget what you have read. This picture is going to give you an anchoring point, right? So when you are having a questions like explain what is the relationship between current, voltage, and resistance. So look at this picture that you have drawn. My picture is ugly, but I'm sure your picture is more presentable. So you can start talking about the push, which is the voltage. Then you can start talking about the current, which is the ampere, the vampire. Then also you can start talking about the resistance. Eric, there's echo. I'll have to mute you first. Okay, right. So from there, you're able to explain first what is voltage, what is current, what is resistance, exactly as what Yunjie explained just now. Then if you want to go a bit more detail, you can tell about the units that is being used of each of them, ampere, volt, and ohm. Then if you want to go a bit more details, you can tell about the device that is being used to measure current, which is ammeter, voltage, which is voltmeter. Then you can also extend it in saying that voltmeter need to be connected in parallel. Ampere need to be connected in series. Right. On the resistance side, you can also talk about the conductor and insulator. What is the difference? Conductor is having what type of characteristics and versus insulator. The charges is able to flow faster. There's less resistance, right? Then you can talk about the relationship between these three points, right? In terms of a formula, right? So that will complete the entire drawer 2, which is one of the sub-chapter of this particular chapter, big chapter. So now we have completed 2 sub-chapters. Then number 3 is also the same drill. Number 4 is also the same drill. Number 5 is also the same drill. How long do you think you need to take to complete 3, 4, and 5? Just now, Yunjie and Eric took maybe 2-3 minutes. Let's say it's 3 minutes. 3 times 5 is only 15 minutes. In 15 minutes, you are able to have a very well and complete picture about what this chapter is about. Right, what this chapter is about. Is that clear? Is that clear? I think it's clear, right? Yes. So this is the method of how you use to do revision. And this revision method, because we are doing it very slowly, it took, what is the time now? About 10 o'clock. What time did we start? Wait, let me pull it out. What time did we start? Yes, we start at 8:40. Now it's 9:59 or 10 o'clock. So it's slightly more than 1 hour. slightly more than 1 hour, and I'm quite sure and I'm quite confident you are able to feel that you understood this chapter very well. Now, if we are going into an exam hall now, I'm sure you are quite confident to answer most of the questions, and most of the questions with the right answer. Right? Do you have the same feeling? No one has the same feeling. Okay, yes. At least I got Yin Jie and also Xuan. Eric and Jaden, not so confident. It's not that I'm pressuring you, right? That you put all your thumbs up. Okay, I hope not. I hope you really, really feel what I feel, what I felt. Okay, so now let's test out. Let's test out using the AI. Let me pull out. Where is this? Yeah. Just now I have another class about the same topic, and the student got 10 out of 10. But this time, we will ask for a harder question, because I'm sure if this 10 question is given to you, all of you, you also get either 9 or either 10. Right? Harder questions. Another 10 MCQ. So now imagine that you are in the exam hall. Right? I'm sure you are not able to bring your notes together with you into the exam hall. Right. The only thing that and also I'm sure you will not be able to memorize all the key notes and write it in a note during the exam. Right. Because this is just impossible for you to memorize. But I'm sure it's relatively easy for you to draw this picture in 1 minute during your exam and use it as a reference. Right. So imagine that you are in the exam hall with this picture that you have drawn in less than 1 minute. And let's see whether this is going to help you in answering the questions. So let's start with, okay, let's do the same drill. You read the questions, you tell me which drawer, and you tell me the answer. Let's start with Eric.
Okay. So for question 1, the answer would be
No, you tell me which drawer first.
this would be the first draw. Wait, no. Yeah, no, this would be the second drawer, the second drawer.
Yes, the second drawer, the relationship, right? Okay. Okay, the answer is?
The answer would be 60 battery divided by 0. Wait, is it divided by 0.3a or multiplied by 0.3a?
You tell me.
It'd be divide, right?
You tell me. Oh, Injie, you okay, let's give Eric the
Yes.
chance first.
Um, I think it would be 18 ohms.
18. You remember you made the same mistakes last week? Okay, anyone? What is the right answer? Is it C? Okay, Injie.
So you do so because what am I? Resistance times current is equal to voltage. So we do 6V divided by 0.3, which is 20.
So it's D. I saw Shen also is giving out the answer D. Eric, do you think it's C or D?
D. I'm
You
definitely
remember the
wrong.
last time we had the same questions, and also I was careless and I got it right. I got the wrong answer as well. Remember? No. Okay. D. Jaden, D, right? Okay, so let's see. Did I put D? Yeah, I put D. Okay, so you're actually well done. Okay, the AI is messed up, but anyway, this is D, and the question is the answer is correct. Let's do question number 2. Xuan. Which drawer, which answer?
The third.
Third drawer, yes.
Let me see.
Answer?
C.
C. Anyone have any objection? I'll give you 3 seconds. 1, 2, 3. Let's see. All right. Okay, Yunjie. Which drawer, which answer?
Drawer 3.
All right.
In a parallel circuit with 2 identical bulbs, which statement is correct?
It's a hard question, yes. But hard question is good for smart student like you.
The current is the same everywhere in the circuit. D.
Okay, anyone object the question, the answer? B. Okay, so now we have B and D. Anyone else? Eric and Jaden, B or D? Or A or C, whichever.
I think it might be
B?
D. I think it's D. D.
Okay,
The
Inche
fourth
and
one.
Inche and Eric, D, is it?
D.
Okay, Jaden, Eric, Inche, D. Xuan, B. Okay, we'll put D. Let's see whether it's B or D. Answer is B. Xuan got it correct. Right? Why is it B? Let's read the answer. The current split between branches is not the same everywhere. The potential difference across each branch is the same as the battery. Okay? It's not an easy question, by the way. But well done, Xuan. Okay, let's do Xuan. Question 4.
It's 3.
Question, yes. 3. Yes.
And I think it's B.
You think it's B. The bulb goes off or becomes very dim. What about anyone have any other question? Any other answers? 1, 2, 3. Yes, you're right. Okay, Jaden, question 5.
Make the wire thicker.
Which drawer?
Is it number 2?
Yes. Anyone object on the answer? 1, 2. Okay, Eric, what is the answer?
B. I accidentally put my hand up.
You think it's B?
I think
One
it's
is
D. I think it's D. I actually keep the hand up.
okay. D. Okay, so everyone agrees D. Good. Okay, let's do it for Eric.
This would be the second one, the second drawer.
Yes.
And
Why does the film number?
what? Would it be C? I think it's C.
Anyone object? Okay, let's try. Oh, no. No objection or not the answer. Okay, no objection, I think. Yep. Question 7. Let's go to Inje.
Um, the drawer is 2.
Second drawer.
Yeah.
Okay, maybe it's third or second. It doesn't. Okay. It's not straightforward. Yeah, either 2 or 3, I think.
3. Oh,
Might be 2 or might be 3, but it's okay. It's fine. Tell me the answer, please.
I don't know.
What happened to the current if the potential difference, which is the voltage, double, assuming the resistance stay constant? I think it's drawer number 2. Yes, you are right. The drawer number 2. You do not know? Anyone have answers? Anyone want to help Inje? Okay, answer is B from Xuan Xuan. Why is it B? Can you explain?
How do I explain?
How to explain? Slowly.
Okay, so actually, Ohm's law is like V equals to IR. So if like resistance stay constant, then current is like directly to voltage. So yeah.
Yes. 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 So you remember the formula V equivalent to I times R. V equivalent to I times R. V is the voltage, I is the current, R is the resistance. Right. So it's asking what happened to the current if potential difference is double. Potential difference is voltage, right? So if the V is double and the R maintain the same, what happened to the current? The current also need to be double. Am I right? You understood this? Okay. Yunjie, you understand? So let's give one example. If you do not understand yet, I'll give you one example. Oh, you understood? Okay, then it's fine. Anyhow, I'll give you one example. Now you have V equivalent to I times R. V is 10, I is 0.5. R is what? R is 20. Right, R is 20. So if the V now is increased to 20 and the 0.5 is still 0.5, what happened to the R? The R
You
needs to
have
be
to you
40.
have to double the R.
Yes, excellent. Okay, so question number 8. Let's do Jaden.
So this is drawer number 5.
Yes.
But I think the answer is C.
See, anyone object? 1, 2, 3. Good. Okay, last two questions. Let's go back to, no, let's go to strength. Xuan, what is the draw and what's the answer?
This is like a bit of 3.
Yes,
I
you're
think the
right.
answer is C.
C.
Yeah.
Anyone object? Or Xuan, can you explain why C?
Because the total resistance decrease and then the total current from the battery increase.
Yes.
So
Yes. Okay, for parallel, the more resistance you put in the branch, the total resistance will decrease. When the total resistance decrease, what does it mean? If the voltage is the same, resistance decrease, we have only one thing to increase, which is the current. Yes. Let's see whether it's correct. Yep. Last one. Final boss. Who wants to take it? Let's do Eric.
Oh no. So it would be current would be so it would be voltage resistance equals the equations resistance equals voltage times current. It would be B, wouldn't it? Wait,
I don't know. You tell me.
Hmm.
You remember the formula V equivalent to IR? V equivalent to IR.
Voltage is equivalent to current versus
So I equivalent to what?
I equivalent to
V
current.
divide
V
to,
is
is that right?
so voltage resistance equals current divided by voltage.
Yes, but it's not asking about your resistance. It's asking about your current. So current is I. I
Current
equivalent to V.
is
V is what? V is 6 divided by
6
R,
divided by R.
which
6
is
which would A would be 0.5 A.
0.5.
Yeah, 0.5
Okay.
A.
Anyone object? 1, 2, 3. Excellent. Okay, this question is a bit tough, but still, all of you got 9, Xuan got 10, which is excellent result. So what does it mean? It means you have already understood the chapter very well. And this is, I'm not sure about IGCSE way of exam. I know SPM, which is the Malaysia exam. You have objective question, which is MCQ. You have structured questions, and you have essay questions. So at least for the objective questions, I'm quite sure you will be doing very well if you are taking the exam. For the essay questions, we did some exercise just now. We try to have Yunjie and Eric to explain drawer 1. Explain to me what is electric charges. Then Yunjie explain to me what is voltage, current, and also resistance. And you guys able to explain it, right? You remember, Eric, you talk about the pen. You talk about the proton, electron, neutron. Then you talk about the charges, positive, negative charges. And then also I help you to start to think about how to explain the repulsion and also attractions. And then we also added in a bit of the electron transfer, how the electron transfer, right? You can put more words and put more explanation in it. really depending on the question. If the question is only 2 points, 2 marks, then don't spend 20 minutes to write all the answers that is in this picture, because it doesn't justify. If it is 20, of course, then put everything that you know in the questions. Same goes to Yunjie. You talk about the definition of current, voltage, resistance. You talk about the unit. You haven't talked about the device that is used, but now you already know. Next time, if you have these questions, you know what to add in. And also you can talk about the conductor, insulator, and also you can talk about the relationship between the V equivalent to IR, right? So on and so forth. Drawer 3, drawer 4, drawer 5, right? And you can also talk about the things that you have learned using this brain drawer method in a very structured way, right? So yeah, today's class is completed. I hope everyone learned something new. Not only revising what you have learned last week, is not just a revision. This is not just a revision class. Is to using this chapter to show you how to do revision. All right. How long do you take to do this revision? If you do it by yourself and you have done it quite sometimes, you practice it, I think less than 1 hour. You see, 1 hour, 2 hours to study, 1 hour to revise. Total is only 3 hours. And if you need to do another revision, I'm sure at that time it's going to be less than 1 hour, maybe 45 minutes, maybe 30 minutes, because it's going to be faster, right? And using that 30 minutes, you can refresh the whole chapter once and for all again. And if you have 10 chapters, you only need to take how many hours? 2.5 hours. No, 5 hours. Right. 5 hours. 5 hours, you can finish the entire revision of your entire science. If your science has 10 chapters, I don't think you have 10 chapters. I think it's only 8 chapters. Right? Does it make sense? Any more questions before we leave? Hello? Okay. So far, so good? Right. Okay, again, congratulations. And see you next time. Bye-bye.
Bye.
Bye.
Bye.